In this video, I will be discuss about the third temperature sensor, that is the thermocouple. So we will discuss about its working principle, then its working, then construction, then its types and advantages, disadvantages, and application. So first, thermocouple. So what is this? This also temperature sensor, and this word thermocouple, which combines the two word, that is thermo and couple. So thermo, which is related to heat or temperature, and couple means the pairing. So it measure the temperature when these two metals are connected in pairing form. So this exactly not measure the temperature, it sense the temperature, and this temperature measure in the form of electric current or the EMF. So here two wires of different metals are welded together at the end and to form a junction, and from this can calculate the EMF. So this thermocouple is used for very high range temperature, very high temperature range, and this range of thermocouple depends upon their type. So working principle. So the working principle of thermocouple depends upon three effects. First is Seebeck effect, second is Peltier effect, and third one is the Thomson effect. This Thomson effect can be divided into two types, that is the positive Thomson effect and negative Thomson effect. So first effect is the Seebeck effect. So in this effect, this Seebeck states that when two dissimilar conducting metals are connected to each other to form a two junction, out of which one junction is subjected to high temperature and another junction is subjected to low temperature, then this electromotive force, that is the EMF, is induced is proportional to the temperature difference between two junction. So from this figure we can see that two different conducting materials are connected in such a way that to form a two junction, that is junction 1 and junction 2. So one junction is subjected to at a high temperature, means this given flame, and other one is kept like this. So hot junction is called as a measuring junction and cold junction is called as a reference junction. Then EMF is produced, and this EMF is measured, which is proportional to the temperature difference between both junction, means the temperature difference between hot junction and cold junction. Then second one is the Peltier effect. So in this effect is also same as Seebeck effect, but which is inverse of Seebeck effect, means which is opposite of Seebeck effect. So here we can see from this figure that here two dissimilar metals are connected and form a closed loop, but if externally current forced to flow through this closed loop, then one junction will get heated and other will become a cold, means this is the same as the Seebeck effect. But in this Seebeck effect we subjected, means we are given temperature to the both junction, and from this electrical motive force or this current we are measuring. Here we are giving firstly current, and from that we are calculating the temperature at both junction, means which junction is cold or which junction is hot. So these are the same effect, but only this is a reverse. So examples, means this Peltier effect is used for aircraft cooler, heater, and in water extraction. So I hope you understand the concept or difference between the Seebeck and Peltier effect. So third one is the Thomson effect. This is the same as both that Peltier and Seebeck, but in this effect this potential gradient exists when in a single even in a single conductor having temperature gradient, and if temperature gradient exists along any one metal, then junction EMF may be slightly altered. So From this figure we can see that here only one conductor is uses in previous effect, that is Peltier and Seebeck, here two metals are used, but in this only one conductor or metal is used, and temperature difference is created or maintained at both side, means different temperature maintained at both side, and current gives to this conductor. Then when this current gives to this conductor, then this wire or this metal will get heated or cold depending upon their type. So these types are positive Thomson effect and negative Thomson effect. So why this is divided into two types? Because if there is one wire is there, and up to this this, so there are three parts. So I will explain how this effect are involved. So when current flows through this hot end, and current flows from hot to cold to hot in this direction, then this there is chance to get this wire will become to get hot, means if current flows from in this direction, then wire will get from cold to hot. Otherwise, if current passes from in this direction, hot to cold, then this wire should be get hot to cold, means this is energy is absorbed. That's why this is a positive positive Thomson effect. When in another that is the in negative Thomson effect, there is also two parts. So when electric current is passed through this conductor, and when this current is moving from this direction, that is cold to hot, so this wire should get hot, but this will not get hot, this will remain cold. Otherwise, if this current is passed from this direction, that is a hot to cold, then this wire this should not be cold. Instead of that, this wire will remains hot. So this is called as a negative Thomson effect. Means when this heat is absorbed, then this time is called as a positive Thomson effect, and when this heat is evolved, that time this is a negative Thomson effect. So this construction, so it consists of the two metal wires are connected together at junction end, and this junction thinks the measuring end. So this from this junction type from this junction, so there are three types. One is grounded junction, another is ungrounded, and third one is the exposed junction. So first is the grounded junction. So from this figure we can see that this is the most common type of junction, and here the junction is connected directly to the probe tip. So this junction is connected probe via soldering or welding, and it is the high thermal conductivity. Why? Because this thermocouple making direct contact with sheath. That's why this has required means to travel the heat, the time required to travel heat is very less. That's why it has high thermal conductivity, and provides the durable protection for junction inside the probe tip. Also used for measuring the temperature in corrosive environment. Then it provides the resistance to noise, but this has one advantages, that is drawback, is the thermocouple. This type of in this junction, this thermocouple is more susceptible to electrical interference. Why? Because sheath is comes into direct contact with surrounding area and providing the path for interference. That's why this interference generated. That's why this is susceptible to electrical interference. So now second one is the ungrounded thermocouple junction. So in this type, which is similar to grounded, but here this junction in that this protective probe is inside, but means this is not welded or soldered. So instead of this welding, here this surrounded this junction is surrounded by the insulator, and for insulation this magnesium oxide is used. So this is used for high pressure application. Then it reduces the stray magnetic field and slow time response. Why? Because heat must be travel from probe tip, then magnesium oxide, so it requires more time. That's why this response time is more. So from this figure we can see that this isolated protective sheath is present and insulation is also there. So third one is the exposed junction. So here this consists of the two bare wires that are joined outside of the protective metal probe. So this is used for the temperature of gas, to measure the temperature of gas, but this gas should not be contain any moisture or liquid or solid contaminants. So this is very fragile, and it requires less time, because means faster response time, because this thermal energy does not have to travel through this metal sheath. That's why it requires less time. So now working. So how works means how work this thermocouple. So this is a circuit diagram. We can see that circuit diagram. So here two dissimilar metals are connected in such a way that to form a two junction. So this P and Q, this P and Q, these are the two junction, and at two junction there are two different temperature is maintained, that is T1 and T2. So one junction is kept at hot, this is subjected to hot, and other one is the cold. So hot junction is called as a measuring junction, which temperature we have to measure, and second one is the reference junction. And so this EMF is generated in this thermocouple. So this EMF or this current is measured using this moving iron instrument. So EMF is generates in this circuit. So if this EMF, if this temperature is equal, means is T1 and T2, these are two temperature. So if this temperature is equal, then EMF generated in this thermocouple is equal, and there is no current flow, that is a zero current flows. But if this temperature is in unequal, then magnitude of EMF induces, which is depends upon the type of material which are making which are used for making the thermocouple. So EMF induces in the thermocouple we can measure by the formula, that is E is equal to A delta theta plus B into delta theta square. So delta theta, which is the temperature difference between thermocouple junction, and A and B, these are the constant. So moving iron instrument, so we can measure this obtained EMF or current from this moving iron instrument. So instead of means in this instrument we can use multimeter, otherwise amplifier or potentiometer. So means it is the if you use this multimeter, then it is connected to cold junction of thermocouple, and deflection of multimeter pointer is equal to the current flowing through the metal. Otherwise we can use DC potentiometer, this gives directly reading. Then amplifier circuit, because the output of this thermocouple gives in millivolt, so this cannot directly shown on this digital circuit, or in we cannot display on a computer. So we have to amplify this output of this thermistor, that's why this amplifier circuitry is used. So like this we can measure the output of this thermocouple, sorry. So types, so there are different types, that is the type K, J, type T, type E, type N, type S. So these types are vary depending upon their temperature range, or which metals are which metals they are using. So this thermocouple is surrounded by safety sheath, and this safety sheath will reduce the corrosion effect drastically, also reduce the rust. So this is table. So table shows the different types and which type are using which conductor. So for example, I am giving this K type, that is a very common type, and this is most commonly used type. So this K type is uses this nickel chromium and nickel aluminum, because this thermocouple consists of the different metals. That's why one is nickel chromium, that is the positive leg, means leg is nothing but the first wire, and second is the nickel aluminum, this is the negative end, negative leg. So temperature range of this type is 0 to 1260 degrees centigrade. With respect to this, it changes 32 to 2300 Fahrenheit. And second, this right side part, which is shown like, means this is a graph. So this shows the relationship between the temperature and this millivolt for this type. So K type, which is shown very linearly. So from this we can calculate, means we can choose the thermistor type for our application as per their requirement. So now advantages. So accuracy is high. It is used for a very high temperature range. Then its cost is low and extremely consistent. Then thermal reaction is fast. Then disadvantages is low voltage, because it gives very low voltage, that is millivolt and microvolt. So we have to require this amplifier circuitry to amplify the output. Then reference is required. Then least sensitivity, and this calibration is very hard. Now this application. So mostly thermocouples are used for the application where we want to measure very high temperature, means for example in industry, that is the boiler, or in a furnace there is very high temperature. So this one this junction, that is the hot junction, is kept at this point and measure the temperature. So this also used in thermostat in offices, homes, of business, like this. So then used in industries for monitoring the temperature of metals in iron, aluminum, because this temperature is very high. Then heat pump for performing the thermoelectric cooling. Then it is chemical plant, petroleum plant, and then gas machine for detecting the pilot flame. So thank you guys for watching this video. I hope you understand this concept and you learn something new. So please don't forget to like, share, comment, and don't forget to subscribe to my channel.